This video looks at rational and irrational numbers. Our QCAA subject matter is to prove simple results involving numbers, express rational numbers as decimals, and vice versa, prove irrationality by contradiction. Our skills prove express, and success, you'll be able to apply your knowledge to correctly complete the set questions. So expressing rational numbers as decimals, A 3/25, the easiest option here is to change it to a denominator of 100. So you are timesing by 4. So you do the same to the top. 3 times 4 is 12. So that is 0.12. For 3/80, easiest option here, change your denominator to 8. So you're dividing by a single digit. So you've divided by 10. Do the same to the top and you get 0.3. So we have 0.3 divided by 8. 8 into 0 you can't do, 8 into 3 you can't do, add a 0. 8 into 30 would be 3 times, 3 8s are 24. So that leaves a remainder of 6. So now you have 8 into 60 is 7, 7 8s are 56. So that means we're carrying 4. 8 into 40 is 5. So therefore, 3/80 equals 0.0375. 1/6, we can just do the division. So we've got 1 divided by 6. 6 into 1 you can't do. Put in the decimal point, add a 0. 6 into 10. Don't add a 0 on top though. 6 into 10 is 1. And there's 4 left over. 6 into 40 is 6. 6 6s are 36. So there's 4 left over. So you can see that's going to keep recurring. So therefore 1/6 equals 0.16, and that 6 recurs. If you wanted it as approximate, it'd be 0.17. Expressing recurring decimals as fractions. So part A, 0.2 recurring. So let x equal 0.222, and that keeps going on and on. We have 1 digit recurring, so 10x is going to be 2.2222 recurring. So equation 1, equation 2. So if you go, what's 2 minus 1? 10x minus x is 9x. And you can see here that those recurring digits will be eliminated. Okay, so you've just got 2.22222 minus 0.2222, which gives you 2. Divide both sides by 9. So x equals 2/9. So therefore 0.2 recurring is equal to 2/9. Okay, 0.123 recurring. Let x equal 0.1232323. 10x would be 1.232323. Now, if we subtracted these, we'd still have a decimal because our decimals aren't matching. We need to be able to match our decimals. If I go 1000x, I get 123.2323, etc. So you can see now that those digits are now repeating. So I times by 1000 to get to those repeating digits. So now if I have equation 1 and equation 2, and I go 2 minus 1, 1000x minus 10x is 990x. And on the right-hand side, I have 123.2323 minus 1.2323. So I'm left with 123 minus 1, which is 122. divide both sides by 990. So I get x equals 122 over 990, and then I need to simplify that. If I divide top and bottom by 2, I would get 61 over 495, and I can't get any lower than that. So therefore, 0.123, where the 23 is recurring, is equal to 61 over 495. Further proofs by contradiction. Prove that the square root of 2 is irrational by contradiction. So if we're doing it by contradiction, we need to assume that the square root of 2 is rational, okay? Because we're doing it by contradiction. So suppose square root of 2 is rational. That means it can be expressed as the ratio of two numbers AB, where AB are integers, because that's the definition of a rational number. Now we're going to assume A and B have no common factors. Because if it did, it could be simplified, that fraction. Okay? Or could be simplified. So what we have now is we have the square root of 2 equals A over B. Square both sides. So we have 2 equals A squared over B squared, which means A squared has to equal 2B squared. Okay? So that means A squared, write that a bit better, A squared is divisible by 2. Okay? Which also means that A is divisible by 2. So therefore, A equals 2k, where k is some integer. So therefore, A squared equals 2b squared. We can replace it with k. 2k all squared has to equal 2b squared. 4k squared has to equal 2b squared, which means 2k squared has to equal b squared. Running out of room, so we'll come up here. So that means b squared is divisible by 2. Which means b is divisible by 2. So that means, therefore, A and B are divisible by 2. But we started by saying, assume A and B have no common factors. So therefore, we've got a contradiction. Okay, we have this contradiction now. Because we went A and B have no common factors. So therefore, square root of 2 must be irrational. Because it's not rational, which we prove by contradiction. Okay, because by proving that it's not rational, it can't be expressed as a ratio of two integers. That means it has to be irrational. Let's look at the next one. Suppose x satisfies 5 to the x equals 2. Show that x is irrational. So again, we're proving by contradiction. So what we're going to do is we're going to suppose that x is rational. So we do the opposite. Now, since x must be positive, x equals a over b, where a and b are positive integers. So therefore, we've got 5 to the x equals 2. And we can write that as 5 to the a over b. I write small enough. Has to equal 2. So to get rid of that a over b, or to get rid of the fractional power, we're going to put both sides to the power of b. So that means those b's cancel, and we're left with 5 to the a equals 2 to the b. Okay, now 5 to the a is odd. 2 to the b is even. Now that can't be right. That gives a contradiction. You can't have odd equals even. So therefore, x is not rational. It must be irrational.